This is Introduction to Statistical Learning, and we're just starting Chapter 9, which is all about support vector machines. The first question here, first conceptual question, is pretty basic, so we don't get into the heavy machinery just yet, but here's the question. So we're going to sketch a hyperplane following this formula right here, and then we're going to indicate which points are greater than 0. So you'll see that this is a line, and so we'll indicate points for which this expression is greater than 0 as well as below 0. And then on the same plot, we'll sketch another hyperplane, or in this case, that just happens to be a line. And again, sketching the points above and below 0. So, you could do this in something like PowerPoint or just pen and paper or something, but I'm going to use some R code here. So the first thing I'm going to do is get my hyperplane 1 put together here. So I need to plot x1 against x2, all right? And so the way that I'm going to do that is I'm going to solve for one of these variables. And so the one I'm going to solve for is going to be x1 because x2 is already all by itself. So you take x2 over to the other side, subtract 1, divide by 3, and that gives you x1 for hyperplane 1, okay? And x2 is just a sequence of numbers, right? So x1 is responding to x2, but you could have done it the other way. And then I'm going to plot it, and that'll be that. And then I've also calculated all of the values for hyperplane 1 here, and that way we can we can look at random points and say whether or not they're above or below that value. Okay, same thing for hyperplane 2, which is right here. This time I'm going to solve for x2 because x1 is all by itself, so you subtract x1 over, subtract 2, divide by 2, and then you get the corresponding values for x2. Okay, I hope I said that right. Subtract x1 over, subtract 2, divide by 2, and then you have x2 in terms of x1. Okay, and so we'll draw that. And once again, I have I have the different values for hyperplane 2. And now I'm going to make so now these are going to sit on a plane where x1 is one of the axes and x2 is another one of the axes. And so that is going to form an entire surface of points. And so I'm going to find a grid of points set along that that x1 by x2 plane. Okay. So I just have a grid of points that are all going from -10 to 10. And then I look at every combination of the x1 axis and the x2 axis. Okay, with this expand grid thing here, I call them x1 and x2, okay, of the grid sequence. And then I just find hyperplane 1, hyperplane 2, which is just my lines that will have been drawn. And then I instantiate a rule that says that if we are greater than the value for hyperplane 1 or hyperplane 2, we call it blue, and otherwise, if it's below it, we call it orange. There really should be a second one in here, which is, or a third one in here, which is for white. Or I'm sorry, if this point equals exactly the line. I'm just going to ignore that, I think, for simplicity. But in theory, you could come up with a point that sits exactly on the line here, but we're just going to ignore that. So now I'm going to plot these different points, x1 against x2, and I'm going to plot them twice. Once is going to be in reference to hyperplane 1, and so that's going to use this color scheme for hyperplane 1. But I'm using a marker that is a filled marker. And then for hyperplane 2, I'm going to use a different marker, which is an empty circle. So what you're going to see, and you can kind of see it down here, but I'll zoom in. But what you're going to see is that the points are going to be duplicated, and if they are, and then the points representing the reference to hyperplane 1 are going to be filled circles And then in reference to hyperplane 2, they're going to be points on the same circles, but it's just going to be an outline of the filled part, right? So if you look at the whole point, the filled part will tell you its reference to hyperplane 1, and the outline will tell you the reference to hyperplane 2. Okay, and so this is what we get here. So blue means greater than one of the two lines. So let's zoom in on this. Okay, so here's hyperplane 1, the solid line, and then hyperplane 2 is the dotted line. And so first let's look at hyperplane 2 because it's a little bit more intuitive. Okay, so hyperplane 2, it is represented by it's the points in reference to hyperplane 2 are the outlines of the circles. And so if we are if it turns out that a point is less than the value of hyperplane 2, then we have a yellow outline. And so you see the yellow outlines basically everywhere below the line here. Okay, and if we are above the value for hyperplane 2, then we have a blue circle, outline circle. Okay, and now similarly for hyperplane 1, we are looking at the filled portion. Okay, and so if a point is greater than the value for the hyperplane, then we have a filled part, right? So there's a filled part right there. Okay, so all of this over here, and in fact everything to the right of this line is filled. Okay, and then everything to the left has a yellow filling, which indicates less than the value of hyperplane 1. Okay, so this is what you get. Okay, I guess that is it.